just a little bit of history. The first major defense procurement was in 1794 with a Department of the Navy order for 6 frigates. Only 3 of those frigates, ironically enough, were built because of a cost and schedule overrun. The essential process from the late 18th century through the mid-20th century was what's called allocative planning, which is at the very top level, you have the defense budget, and that defense budget would be broken down among the services in a arguably arbitrary, arguably politically influenced, and those aren't the charitable ways of looking at it, process throughout the services, and they would allocate that budget to whatever their top-ranked programs that they wanted to pursue. But there was no tie back to what are the capabilities that we actually need as a nation to effect a comprehensive defense. So 1960s, specifically 1961, Robert McNamara completely transformed the acquisition paradigm. And this was truly a profound transformation. So before I start criticizing McNamara, let me build him up a little bit. Because PPBS, which today survives as PPBE, which is the system that he instituted, was truly a work of art. What we have today is by far the most sophisticated acquisition process in any industry and in any country, and the Defense Department is far ahead of other federal agencies, many of which still use allocative planning, the 18th century mechanism, if you will. So it is truly a work of art, but it is about almost 50 years old now, and so what I want to talk to you here about today is, are there potential changes and modifications that could be made to incentivize the deployment of such favorable system attributes as modularity. So specifically, I'd like to focus on the programming aspect of PPBS, and what programming essentially is it's also called system analyses or analyses of alternatives. It is deciding which system is best for effecting a particular capability, which architecture is best for effecting a particular capability. And the crux of programming or systems analyses is, what is the criterion by which you decide that one system is better than another? And in 1960, a gentleman named Charles Hitch, who headed the economics department of the Rand Corporation, published a book which is available free online as a Rand report today, called The Economics of Defense in the Nuclear Age. And the book was truly earth-shattering. It's not a particularly popular book, as you can imagine, but it is a very, very interesting read even today in the profundity of many of the points made there. And what Hitch proposed, and by the way, I should say that McNamara in 1961, after he read the book, brought Hitch in as the comptroller of the Pentagon to implement PPBS. So the roots of PPBS are in this book. And what Hitch originally espoused before he came to the Pentagon is that the appropriate metric for selecting systems, for selecting among different alternatives for affecting a particular capability, is maximizing gains minus cost of a system. To put that in modern economic parlance, that's maximizing the net value of the system. And again, that comes as no surprise if you come from the commercial world. Net present value, NPV, is the sole criterion. It emerged only in the 1970s, 1980s as such, and today is taught unequivocally as the sole criterion for appropriately selecting among alternatives in business. And back in 1960, Hitch was advocating this for defense projects as well. And he acknowledged that it is frequently very difficult to make gain and cost, the value of the system and the cost of the system, commensurable. So putting them in the same units such that you can subtract one from the other. It's a difficult problem. It was a difficult problem then. It is a difficult problem today. But in the last 50 years, economics, microeconomics, and finance has developed a variety of tools that allow us to do this. However, in 1961, many of those tools didn't exist or weren't mature. So in 1965, after the implementation of PPBS in 61, Hitch published another book, which was a retrospective now on PPBS, and it's very interesting to compare because what they ended up with is they wanted to implement a criterion that was gain minus cost, or essentially a value criterion for system acquisition. But what they ended up with, and Hitch pawns the responsibility off to McNamara for this, is we ended up with a criterion that fixes the capability of a system and minimizes cost. And at a perfunctory level, that seems like it's exactly the same thing, right? If you fix capability, if you essentially fix gain and you minimize cost, well, isn't that the same thing as maximizing gain minus cost, right? And that is true in certain cases, but it's not true in other cases, and that's what I turn to in a second. So what is the new paradigm that I'm proposing to you here today? And that essentially is one that goes back to Hitch's original work, the 1960 work, which suggests gain minus cost. I think that's an unwieldy term that's overcome by modernity, if you will. So I'll use value instead. But in essence, net value is synonymous in my usage. And so what you see at the top here is a plot for, again, this is a notional space system, but you can construct this for any sort of system, of value and cost over the life cycle of a system. In red is the cost, and in black is the value. And you see the development process, the launch spike for a space system. Again, that's not material to the argument here. And then you see the deployment of capability, and the system starts to generate value for the user. Now, so again, if you look at that picture, saying I'm going to maximize value minus cost is exactly the same as saying I'm going to fix value and I'm going to minimize cost, right? So what's the point? Why am I even talking about this, right? I mean, they are synonymous, right? That's what McNamara said, but they aren't, right? Because that is the perfect world. And there's a variety of things that happen throughout the life cycle of any system, perturbations or risks or uncertainties that take place that perturb that perfect life cycle picture of the system. And so some examples are depicted at the bottom, and I think, yes, they are enumerated in greater detail here, and they include things like funding fluctuations. You might have a funding cut to the system. You have to replan, redesign the system. You might have a requirements change. You might have a launch failure. You might have an on-orbit failure that perturbs this clean picture of the system. And different systems will respond to these uncertainties in different ways. And the manner in which the system is essentially resilient to these uncertainties, perturbations, or risks, however you want to call them, is described by two broad terms and a variety of subterms under those. And the two broad ones are flexibility of the system and the robustness of the system. And the typical other ilities, so to speak, are encapsulated under those two broad rubrics. And so just to define so that everybody's on the same page, what is flexibility? Flexibility is the ability of a system to change on demand. So if a system is perturbed, so you have, for instance, a funding cut or demand increase during the operational life of the system, what are the options that the owner or operator of the system has to respond to those uncertainties? And those options manifest themselves as different types of flexibility. So the ability to scale the system, the ability to adapt the system, evolve the system, maintain the system, et cetera. Robustness, on the other hand, is the intrinsic response of the system to various uncertainties. So whereas flexibility has a human in the loop, these are options that the owner of the system has, robustness is the intrinsic response of the system, either to exogenous or endogenous perturbations. And exogenous perturbations could be a hostile event, so an anti-satellite launch against a satellite. And endogenous things are internal failures. So reliability and survivability are both encompassed by the broad notion of robustness. So those are two attributes of a system that emerge in response to life cycle perturbations. And both of those attributes, I would argue to you, have value. And that value is lost in the minimum cost formulation of the acquisition metric of the analysis of alternatives metric. And the reason is because you fix capability, and you don't fix capability by saying I would like the system to have this degree of resolution, this field of view, this other kind of performance attribute, and by the way, 10 kiloflexes of flexibility. Because there are no good metrics and uniform metrics for measuring flexibility and for measuring robustness as a performance attribute. They're not considered as part of system performance. So when you minimize costs for a given level of performance, you ignore flexibility and robustness. And by ignoring them in your primary acquisition metric, you essentially disincentivize their inclusion if their inclusion is going to increase your size, weight, or power of the system or the cost of the system.